Welcome. We will now review cloud networking and Amazon Virtual Private Cloud, also known as Amazon VPC. We will begin by reviewing fundamental concepts of AWS Cloud Networking, and you will then learn about the VPC as the foundation of an AWS Cloud Network infrastructure. After that, you will learn detailed information about the components that are defined in a VPC and examine some key configuration settings. In its most basic form, a cloud-based network is a private IP address space where you can deploy computing resources. In AWS, this private network space is provided by Amazon VPC. With a VPC, you define a virtual network in your own logically isolated area in the AWS cloud. You can deploy AWS computing resources inside the virtual network, such as Amazon EC2 instances or a database from the Amazon Relational Database Service. You can also define how and whether your private network space connects to endpoints in your network topology. In this example, a VPC contains 3 EC2 instances and 1 RDS instance. It is connected to the internet and the corporate data center. It is also connected to a secondary VPC. As a systems operator, you control these components. That's why it is important that you understand how to configure and use them. This diagram shows the main AWS networking components that reside in a VPC. It also highlights the key components that allow it to connect to external clients. A VPC can span multiple availability zones. Here's a detailed review of each VPC component we see here. First, there's a subnet. Subnets are logical subdivisions of your VPC. They enable you to segment your VPC into smaller networks in a single availability zone. The default setting of a subnet is private. When created, a subnet is an isolated segment in a VPC. A subnet is public if its route table contains a reference to a public internet traffic being processed by an internet gateway attached to the VPC. A subnet is required to deploy an instance into a VPC. The next component is a security group. A security group is a set of firewall rules that secure instances. They allow you to define inbound and outbound traffic to an instance. If you do not specify a particular security group at launch time, the default security group is used. A NIC is a virtual network interface that connects an instance to a network. Each instance in a VPC has a default network interface, also called the primary network interface, which cannot be detached from the instance. A router is a component that routes traffic within the VPC. Normally, you don't deal with a router, but instead you define route tables and attach them to subnets. An internet gateway allows communication between instances in a VPC and the public internet. A virtual private gateway can be defined on the AWS side of a virtual private network connection, also known as a VPN. A VPN connection provides a secure and encrypted tunnel between 2 network endpoints. A customer gateway is either a physical device or a software application on the client side of a VPN connection. When you create a VPC, you specify its allowable IP address range. This range represents IPv4 addresses. The IP address range is expressed as a classless interdomain routing or CIDR block. This required range is known as the primary CIDR block of the VPC. After you create the VPC, you can optionally add up to 4 secondary CIDR blocks for a total of 5 IPv4 CIDR blocks per VPC. You can only define VPCs with CIDR blocks of /16 through /28 inclusive. This means that a VPC can contain from 16 to 65,536 IP addresses, with a maximum of 200 subnets per VPC. As a best practice, restrict your range to addresses that are specified in RFC 1918. RFC 1918 defines the range of addresses that can be used by private networks. We recommend that you do not use a range that overlaps with addresses that are used by other VPCs. Doing so prohibits you from connecting these VPCs. You can also assign an IPv6 CIDR block that is provided by AWS. This CIDR block uses a fixed prefix length of /56. You cannot choose the range of addresses or the IPv6 CIDR block size. AWS assigns the block to your VPC from the AWS pool of IPv6 addresses. Remember, you can only have one IPv6 CIDR block per VPC. This AWS CLI command generates the VPC that is shown in the console screen capture. If the command completes successfully, it returns metadata about the new VPC. This metadata includes information like the ID and the state, which will show as pending. The CIDR format is used to specify IP address ranges when you create a VPC or a subnet. An IPv4 IP address is a 32-bit number represented as 4 numbers separated by periods. Each X is an 8-bit number, or a byte, that you can have a value between 0 and 255. The IP address is logically divided into a network prefix and a host identifier. The network prefix identifies the network, and the host identifier identifies the host. /n specifies the length in bits of the network prefix portion of the IP address, starting from the leftmost bit. For an IPv4 IP address, the value of n can be between 0 and 32. In a VPC, the value of n is restricted to between /16 and /28. In general, the larger the value of n, the smaller the range size becomes, which results in a smaller number of usable IP addresses. The table provides examples of CIDR block ranges, their corresponding bit representation, and their resulting address range. The first 4 IP addresses and the last IP address in each subnet CIDR block are not available for you to use, and they cannot be assigned to an instance. AWS reserves these. For example, in a subnet with CIDR block 10.0.0.0/24, the table depicts the 5 IP addresses that are reserved. For VPCs with multiple CIDR blocks, the IP address of the DNS server is located in the primary CIDR block. This diagram illustrates the main characteristics of a VPC. VPCs can span multiple availability zones in an AWS region. VPCs have an implicit router that routes all traffic in the VPC. VPCs have a default route table that specifies the allowed routes out of the VPC. This table defines a route, or rule, that allows all traffic for its CIDR IP address range to be routed locally. In the example, the VPC has an address range of 10.0.0.0/16. Therefore, its default route table has a rule to route all traffic that is destined for that range through the local route. Next, we examine how subnets and route tables are used in a VPC. Now you will learn about subnets in more detail. We mentioned earlier that you can create subnets to further segment the VPC address range and provide logical groupings for resources. For example, you could create a separate subnet for resources of different types, such as EC2 instances and database instances. You could also create a subnet for resources with different levels of visibility, such as public or private. You can also use subnets to divide resources by team or department. You can create up to 200 subnets per VPC. For IPv4, the minimum size of a subnet is a /28, or 16 IP addresses. For IPv6, the subnet size is fixed to be a /64, and only one IPv6 CIDR block can be allocated to a subnet. For more information about subnets, Search for VPC subnet basics in the AWS online documentation. This diagram illustrates the following characteristics of subnets. First, subnets can only exist in one and only one availability zone. Next, the address range of a subnet CIDR block must be a subset of the address range for the VPC. Subnet CIDR blocks in a VPC must not overlap. This is true in the diagram for the two subnets, which are comparing the third octet. Finally, traffic to and from each subnet flows through the implicit router of the VPC. After you create a subnet, you can specify whether you want to automatically assign a public IP address to new EC2 instances that are located into the subnet. This is useful for a public subnet that is intended to host EC2 instances that are accessible to internet clients. Before an instance can be publicly accessed, it must be assigned a public IP address. By enabling this subnet feature, you can automate the assignment of an IPv4 or IPv6 address to EC2 instances that are launched into the subnet. To enable this setting in the VPC console, go to the Modify Auto Assign IP Settings configuration page for the subnet. Then select the Enable Auto Assign Public IPv4/IPv6 address checkbox. Note that the assigned IP address is not an elastic IP address. The assigned IP address will be released from the instance when the instance is stopped or terminated, unlike an elastic IP address, which is a static IPv4 address that is reachable from the internet. Each VPC comes with an implicit router that directs traffic between the resources in each subnet. It also directs traffic out of the subnet. The router uses a route table to determine valid IP destinations out of a subnet. It also uses the route table to determine the corresponding target that is used to reach the destination. A route table is a mechanism that routes traffic that originates from an associated subnet in a VPC. Contains a set of rules, which are also called routes, that determine where traffic is sent. A route table contains a destination and a target. The router reads the route like this. Any traffic that goes to a destination should be routed via the target. A target could be a specific instance ID, a network interface ID, an internet gateway, or a virtual private gateway. When you create a VPC, a default route table is also created. The default route table has a rule that routes local traffic anywhere in the IP address range of the VPC. You can add more routes to the default route table. When you create a subnet, it is automatically associated with the default route table of the VPC. If you do not want to use this route table, you can create a custom route table and associate it with the subnet instead. Each VPC might also have an internet gateway attached to it. An internet gateway is a service that routes traffic to the internet. When an internet gateway is attached to a VPC, route tables that belong to public subnets might use it to forward traffic out to the internet. In the diagram, subnet 2 is associated with the default route table. The single route that is defined in the table states that traffic is allowed out of the subnet only to the IP addresses that are in the VPC address range, which in this case is 10.0.0.0/16. This traffic is routed via a local path. Subnet 1 is associated with a custom route table that has two routes. The first route is the same as in the default route table, which means that local traffic is allowed out of the subnet to the IP addresses in the VPC address range. In addition, the second route, or all zeros/0, states that traffic to any other IP addresses are also allowed. This route also states that this traffic should be routed through the internet gateway that is identified by IG with an ID number. As we mentioned before, an elastic network interface is also called a network interface. The elastic network interface is a virtual network interface, or NIC, that is attached to an EC2 instance. It provides the connection point that allows an instance to communicate with the network. Each network interface has one primary IP address plus additional secondary IP addresses. It also has its own media access control or MAC address and its own security groups. Every instance in a VPC has a default network interface that is called the primary network interface. This interface is assigned a private IPv4 address from the IPv4 address range of the VPC. You cannot detach a primary network interface from an instance. You can create and detach additional network interfaces to an instance. The number of network interfaces you can attach varies by instance type. An additional network interface can be attached to an instance, detached from that instance, and then attached to another instance. The network interface's attributes follow it when it is attached or detached from instances. When you move a network interface from one instance to another instance, network traffic is redirected to the new instance. Two reasons you might need multiple network interfaces are listed here. First, some network and security appliances prefer to be configured with multiple network interfaces. Examples of these appliances include load balancers, network address translation or NAT servers, and proxy servers. You can create and attach secondary network interfaces to instances in a VPC that run these types of applications. You can also configure the additional interfaces with their own public and private IP addresses and their own security groups. Second, if you are connecting an instance to a service that is powered by AWS Private Link, you must create an interface endpoint for it that also creates a network interface. You must then attach the network interface to the invoking instance. We will examine this connectivity option in more details later in this video. When you create an AWS account, AWS automatically creates a default VPC for you with a CIDR block of 172.31.0.0/16. This provides up to 65,536 private IPv4 addresses between 172.31.0.0 and 172.31.255.255. This default VPC enables you to start using VPC features immediately. AWS also automatically creates an internet gateway, a default route table, and a public subnet in the default VPC. The internet gateway allows communications with the internet. The default route table includes rules to send traffic to IP addresses in the VPC address range to a local route. It sends traffic to any other IP address to the internet gateway. The public subnets are set for each availability zone associated with the VPC. The public subnets have a /20 size, which provides up to 4,096 addresses. These subnets have the auto-assign public IP option enabled. This option means that any instance launched in the default VPC automatically gets a public IP address. They are public subnets because they are associated with the default route table, which has a rule that allows traffic through an internet gateway. A domain name system, or DNS server, is used to host and resolve a DNS hostname such as www.example.com to its corresponding IP address such as 192.0.2.1. When you create a VPC, AWS automatically assigns an Amazon-provided DNS server to it for use in resolving hostnames in the VPC. This DNS server is called Amazon Route 53 Resolver. By default, Resolver directly answers DNS queries for domain names in the VPC. It also performs recursive lookups against public name servers for all other domain names. If you don't want to use Amazon Route 53 Resolver, you must use other options. First, you can use your own DNS server. This option requires specifying a special set of Dynamic Host Configuration Protocol, or DHCP, options for the VPC. You can also use an Amazon Route 53 private hosted zone. A hosted zone is a container that holds information about how Amazon Route 53 routes traffic for the domains in a VPC. A public hosted zone allows Amazon Route 53 to route internet traffic to resources inside a VPC. For example, a public hosted zone could allow a customer to view a company website that runs on an EC2 instance. In contrast, a private hosted zone is used by Amazon Route 53 to route traffic in one or more VPCs without exposing resources to the internet. One common use case for creating a private hosted zone DNS is called split horizon DNS. A split horizon DNS pairs a private hosted zone DNS with a public hosted zone DNS. With this implementation, a given DNS hostname resolves differently, depending on whether the lookup comes from inside or outside the VPC. If a lookup is initiated from within the VPC, the DNS hostname resolves to a specified IP address. However, if the lookup originates from outside the VPC, the same DNS hostname resolves to a different IP address. An example scenario for using a split horizon DNS is when you want to maintain internal and external versions of the same website. Split horizon DNS allows you to access the internal version of the website by using the same domain name that is used for the public website. For more information about the VPC, DNS, and Route 53 private hosted zones, search for VPC DNS or hosted zones private in the Amazon online documentation. Thanks for watching. We'll see you in the next video. Welcome. We will now review several methods for connecting a VPC to external entities, including the internet, external clients and endpoints, and other AWS services. First, we will learn more about AWS site-to-site VPN connections. Then we'll review AWS Direct Connect and AWS VPN Cloud Hub. Finally, we will wrap up the video by learning about AWS Private Link and AWS Transit Gateway. The site-to-site VPN option creates an IPsec VPN connection between remote customer networks and their VPC over the internet. The resulting connection is secured by using the IPsec protocol. A site-to-site VPN connection consists of two components. First, you have the virtual private gateway. This is the VPN concentrator on the Amazon side of the connection. To create the VPN connection, you also need the second component, which is the customer gateway. With AWS Direct Connect, which is also known as DX, you can create a physical connection between your data center and AWS. DX creates a secure and dedicated endpoint between your internal networks and your cloud network. One end of the cable is connected to your data center router, and the other end is connected to a DX router in a DX location. With this connection in place, you create virtual interfaces to directly access public AWS services or VPCs. You can thus bypass internet service providers in your network path. A public virtual interface enables access to public services, such as Amazon Simple Storage Service, commonly known as Amazon S3. A private virtual interface enables access to a VPC, and it is attached to a virtual private gateway. When you combine a DX connection with site-to-site VPN, you add IPsec encryption. For more information about creating a site-to-site VPN connection, search for Setup VPN Connections in the AWS documentation. If you have multiple requirements for a VPC to remote site VPN connection, you should consider using the AWS VPN Cloud Hub mode. With the VPN Cloud Hub, you can implement multiple VPN connections to your VPC in a convenient and cost-effective manner. AWS VPN Cloud Hub operates on a simple hub-and-spoke model. It can include both site-to-site VPN and AWS Direct Connect plus VPN connections. The model enables your remote sites to communicate with the VPC and also to communicate with each other. To use the AWS VPN Cloud Hub, you must create a virtual private gateway with multiple customer gateways. Each customer gateway is configured to advertise its BGP routes over its site-to-site VPN connection. These routing advertisements are received and re-advertised to each BGP peer. This enables each site to send data to and receive data from the other sites and the VPC. In the example here, the corporate headquarters in New York City has a DX connection to the VPC. The branch offices use site-to-site VPN connections to the VPC. The branch offices in Los Angeles and Miami can send and receive data with each other and with the corporate headquarters, all by using the AWS VPN Cloud Hub. For more information about VPN Cloud Hub, search for it in the AWS online documentation. Most companies do not migrate to the cloud overnight and immediately abandon their physical data centers. A company might still use their existing data center for some tasks, while they extend their capabilities by hosting specific applications and services in AWS. To support this requirement, AWS provides a number of network to VPC connectivity solutions. This diagram illustrates the main options for establishing a VPN connection between your data center and your VPC. AWS Direct Connect Plus VPN combines the features of Direct Connect with the features of AWS Site-to-Site VPN. Direct Connect creates a dedicated private connection from your data center to your VPCs. It links your internal network to a DX location over a standard Ethernet fiber optic cable as part of a wide area network, commonly referred to as a WAN. It does not connect through the internet. This setup provides privacy and increased bandwidth. The combination of both solutions results in an IPsec-based secure connection that uses a dedicated direct network link. You can create a VPC endpoint to privately connect your VPC to supported AWS services like Amazon S3 and DynamoDB. You can also create a VPC endpoint to services that are powered by AWS Private Link. With AWS Private Link, you don't need an internet gateway, a NAT device, a VPN connection, or a Direct Connect connection. Instances in your VPC do not need to know the public IP address of the resources that they want to communicate with. In addition, the traffic between your VPC and the service provider does not leave the Amazon network. There are two types of VPC endpoints. A gateway endpoint provides direct access to resources in Amazon S3 and Amazon DynamoDB without flowing traffic through the public internet. The gateway endpoint is defined in a route table as the target to the desired resource. An interface endpoint allows you to connect to a service that is exposed through AWS Private Link. It is a network interface that can be attached to an EC2 instance. This virtual interface has a private IP address. The IP address serves as an entry point for traffic that is destined to the target service. Many AWS services can be powered by AWS Private Link. You can also create your own application and configure it as a service that is powered by AWS Private Link. This kind of service is referred to as a VPC endpoint service. In the diagram, an instance that runs in the service consumer VPC wants to connect to a custom service that runs in the service provider VPC without leaving the AWS network. To enable this scenario, you could use an AWS Private Link. First, you implement the service as a VPC endpoint service. You then create an interface endpoint on the consumer VPC side and attach it to the instance, which allows it to connect to the service. The diagram also shows that the same instance accesses resources in Amazon S3 and Amazon DynamoDB without going through the internet. Each service has a gateway endpoint to access its resources. Each gateway endpoint will then route packets directly to the connected service without ever leaving the private AWS cloud. For more information, search for VPC endpoints in the AWS